first AND gate, second pin. Next, again the same B is connected for the third AND gate. Third AND gate. Okay, this is 11, 12 inputs. Now, take the inverted output that is from NOT pin and connect it for the second AND gate, second input, the type. AND gate, first AND gate output is given for OR gate input. That means pin number 3 is the AND gate output given for OR gate, first pin number 1 input, and the second AND gate, that is pin number 6, is given as second input for OR gate, that is pin number 2. And now this OR gate output pin number 3 is taken as sum and same as AND gate, third AND gate, that is pin number 8 is taken as output carry. Now please connect all the 7 pins to ground. Okay, connecting all the 7 pins, 7th pin of each IC to the ground and 16th pin, that means here 14 pin because it is 14 pin IC. So here see here 2 slots are empty. That means these 8th and 9th pin are not considered for all the ICs. So 16th pin becomes 14th pin. 14th pin were connected for VCC plus 5 volts. Now switch on the circuit. Okay, switch on the trainer key. Now we'll check the truth table. That is for 0, 0, sum 0, carry 0. For 0, 0 input, sum 0, carry 0. Now give 1 for B, that is A, B, 0, 1. We'll get sum 1, carry 0. Sum 1, carry 0. Next, A is 1. A1, B0. So the output is sum 1 and carry 0. Now both inputs are 1. Sum 0, carry 1. Okay, this is the 0, 0, 1, 0, 1, 1, 0, 1. Okay, thanks for watching. Please do subscribe and share my video. Myself Ushashri. Now I am going to demonstrate how to design the half subtractor hardware part, that is part B, 4th program, B experiment. Okay, 2 inputs A, B, 0, 0, 0, 1, 1, 0, 1, 1. When you do subtraction, that is from 0, 0, the difference is 0 and borrow becomes 0. When you subtract 1 from 0, the difference becomes 1 and borrow is 1. Next, when you subtract 1 from 0, the difference becomes 1 and borrow is 0. Now when you subtract 1 from 1, the difference is 0 and borrow is 0. Okay, now design the circuit, that is wherever 1, so difference, the circuit is, now difference expression is equal to, okay, A bar B plus A B bar, same as borrow is equal to, that is A bar 1, where we will get output high, that is A bar B. Now we will design this using NOT gate for bar, AND gate, OR gate. Now we will connect first A bar, take one input A bar, B for AND gate. Okay, that is you can take pin number 1, 2 and 3. Same as A, B bar. Take one input from 1 A and other input B bar. NOT gate output. This is NOT gate pin number 1, pin number 2, pin number 1, pin number 2. Okay. Now take here 4, 5, 6. 7 is ground. Next borrow. Connect these two for OR gate. That is pin number 1, 2 and take the output from pin number 3. This becomes difference. Borrow. Take an input from NOT gate. First pin A bar and next B, that is NOT gate input pin and connect with AND gate. Already 1, 2, 3, 4, 5, 6 pins were used. So 8 becomes output, 9 and 10 pins. Now this is the borrow. Now we will design the circuit hardware by using NOT gate IC number 7404 and AND gate 7408, OR gate 7432. Okay, these are all the ICs. Now I am connecting NOT gate IC 7404, 7408. See the notch is upside. No. Okay. Notch is upside. Connect this here and see two slots were empty. Now connecting all pins, that is, and 14th pin, 7th pin, because 2 pin visible, not considering. So after 7th pin, 10th pin becomes the 8th pin. Okay, now I have connected VCC and ground. I will design the circuit. That is, first input, that is, take an input A and connect it for NOT gate first pin, and from this again AND gate 4th pin. The same is connected for AND gate 4th pin. So from A input completed. Now A bar, that means second pin of NOT gate, inverted output taken, and that is first AND gate pin number 1. Okay, and next pin number 9, AND gate pin number 9. Pin number 9 is become. Take the input B input and connect it for NOT gate 3rd pin, and from this AND second pin and AND gate 10th pin, AND gate second pin and the same for AND gate. Next from B bar, AND gate second next input, that means pin number output given for AND. Now AND gate can get output for number 2 OR gate, pin number output of AND gate as input of pin number 2. The out of 3 is taken as reference. And the output of third AND gate, that is pin number 8, is taken as borrow. Now and check table. The difference for 0 different borrow is okay. Next 0 difference in the A. Now both, if both inputs are 1, difference 0 and borrow 0. Thanks for watching this video. Myself, I am going to design hardware circuit C4C. Okay, this is the, when you take and this, will get the expression like this and carry expression yes according to the, this is the design. Gate 1 is 4 and 2 ICs from 1 4 AND gates, IC 3 AND gates. Here 4 are 4 and I am going to design this. Not IC 174084 and 7432 for R and 7408 as use it and connecting A for NOT gate. Okay, connected for input and we need to that input for AND gate. Same for AND gate pin number 1. Next, same for this is the second IC. You take other IC and get. So A same input for this is another AND gate IC 7408. Again same connection for third AND gate pin number 11. Okay, take the output NOT gate that is A bar, and connect it for first gate, another input and gate, and A bar. Now take what is B, connect it for not gate, third pin, and what are all the connections check here, that is AND gate, input, same B input is given for other input for another connections, that is for B, take two inputs and AND gates, new ICs. Okay. Same again, connecting two more inputs, connected for first AND gate of new IC, second IC, and next fourth pin of AND gate. Now take the that is B bar, fourth pin of NOT gate, and check the connections, that is AND gate, fifth, third C for NOT gate, given for the fourth AND gate of first go, that is fifth pin C, 14th pin. Next C again connected for second AND gate and third AND gate. Again C is connected for second IC of second AND gate and third AND gate. Third input C. Now inverted output, that is C bar, sixth pin of and check the connections, that is third AND gate is number 9 of IC, and next connections from C. No other connections from inputs A, B, C inputs work. We will connect C pin and 14th pin VCC. 7th pin to ground and 14th pin to VCC. Pin grounded and 14th pin VCC. 7th pin ground and 14th pin VCC. Now connect the remaining connections. Now we'll connect the first OR gate output to the gate. First output, this gate and OR input OR gate pin of given as an 1 for and the fourth input, and 1 is to get the output, that means 9 output not pin gate. The third and fourth put okay, and for and given OR and is next same as the second. I first get out and second and out for input 8 as put for gate. One more new AND gate that is taken and given as an input for OR gate. Out gate is considered as carry. Now the work completed. Now switch on the trainer kit. Okay, 3 inputs sum and carry is okay. For 0 is C is 0. 0 sum 1 carry 0, sum 1 carry 1 0, sum 0 carry 1, sum 1 carry 1. The output for thank video. Subscribe and share my video. I am going to subtract hardware, that is fourth program. Under that D, this is the subtract input C and the difference and borrow. Okay, according to this truth table, that becomes the difference and once for borrow becomes the this is okay, the same as full adder. See this? Okay, full, and this is the full subtractor circuit. The sum division for difference, and you check this. And for C, wherever A full adder connected for one, I am going to say X full bar into A is 4 and A B C A. Come in C A bar, that is A. Okay, here wherever A is there, it is changing A bar, and B C is constant. And A bar, I'll just actions adder subtractor. I have given A gates, I'll change to A bar. Show the ports. I will check that already shown in previous video. Please watch that video and just do connection. Look at the already. I am switching this table. Okay, 1 0 0 0 0 1. Okay, go on 1 1 1. Okay, and now I am just changing. Check input 0 1 for full 0 1 0 1. Okay, 0 1. Now I'll change this to just that you put I'll and for this connected connect for not pin number 1 third and for borrow. Okay, I'm changing this, that is next AND gate one input that is given from A, I'm changing to A bar. Okay, this becomes the full subtractor. No need to change all the connections, only the inputs you have given from A should change from A to A bar. That's it, enough. Now we'll check the truth table. Switch on the trainer kit. Now check the truth table. Truth table, from the truth table for 0 0 0 full subtractor, difference 0 borrow 0. Next for 0 0 1 difference 1 borrow 1. Next for 1 0 difference 1 borrow 1. For 1 1 difference 0 borrow 1. For 1 0 0 1 0 0 difference 1 borrow 0. Next 1 0 1 difference 0 borrow 0. For 1 1 0 difference 0 borrow 0. Now all ones 1 1. That's it. Very simple. Just change the connections of full adder A input to A bar input. This becomes the full subtractor. Okay. Thanks for watching. Please do subscribe and share my video. Myself Ushashri. Now I am going to demonstrate 8:1 multiplexer hardware program, that is part B 5th program for VTU 3rd sem students. Please do subscribe to my channel, like on, share this video. For we need multiplexer IC, that is 7-1 IC. Okay, this consists of 3 select lines, 0 to 7, that means 8 data lines, data inputs, 1 out, and we need NOT gate, that is IC 7404 IC. Now first we need to design, that is 4 inputs, that is the expression is given y is equal to fe sum p expression 4 10 14. That means for this data inputs we should get y output high, and for all remaining it should be 0. Okay, now this is the, now we are entering the variable, that is see here for 2 is 0 1 2 we should get 1, and 4 1 5 7 14. The output high, and it should be, now is the y. Enter map entered using this entering the, for this we should as well as y. The rules for entering K map using MEV method. Okay, see, if the two values 0 0 1 0, that means here a function 0 0, if this you should enter 1. If both the values 0 and both means value MEV same it should. If suppose this is inverse 0 1 1 0, we should enter the value inverted value. Suppose if you are using don't cares, then 0 1 don't cares means don't care. 0 1 0 don't care, here it is 0 0, so 0. Next 0 don't care, 1 don't care, so it is 0. 0 1 1 don't care, 1. 0 don't care, 1 1, it should be entered 1. Now using this MEV K map, we are entering here the values, that is 0 0 1 0. This combination it is 0, so you should enter 0. Okay. Now 0 1 1 0 inverted values, so D bar. Because this is inverted, 0 becoming 1, 1 becoming 0. So it is entered D bar. Next both are 1, so you should enter this as well, output same, so you should enter D, same value D. Next here 0 0, so take it, enter value 0. Inverted values 0 1 and changing 1 to 0, so inverted D bar. Here 0 0, so you should enter 0. Inverted values again D bar. Okay. These are D0, D1, D3, D5, D7. Okay. This should be given for multiplexer IC data lines input. Okay. Now we will design the circuit using this. Designing the 1 multiplexer, we need one NOT gate 744. See the notch here and place. Same as next multiplexer IC. This is 74151. Notch upside. Place here. Okay. Lock this. Now according to the circuit design, first we need to give the input. I am taking here D. Input is connected. NOT gate first pin. Same. See the circuit diagram. Same data input is given for pin number 1. 1 means that is pin number 1, data line 2. See in this data line 2 is 1. So are connecting. Okay, according to the MC, this is D, that is the same input D, D3. D3 are 3 pin number 1. Okay, D3 is pin number 1. So I am connecting to pin number 1. Next, coming to D bar, that is inverted output taking from, okay, D5 as tap 3, connect, and connect for number three. Pin number pin number 12. Okay, is connected. Now we'll see 1 MEV for D2 pin number 2. 1 means you need to connect C. So pin number 2. As well, for all ICs, you should connect 16 pin VCC and for 14 pin IC, 14th pin is VCC, because 14th pin here 2 slots were empty, so 8 and 9 pins are not considered here. 16 becomes 14 for 14 pin IC VCC. And then 7th pin ground for all ICs. 14 pin ICs. If suppose it is 16 pin IC, 8 pin should be grounded. Okay. Now next, remaining pins, that is 0. D not, that 0, 0, D6, 0. These 3 pins should be, that is pin number 7. Pin number 4. Pin number 7 enable. Pin number 15 enable, we are considering 0. Next, pin number 13. Pin number 13, pin number 15 and pin number 4 are the data lines here is enable, it should be again 0. So all should be given for 0 means grounded. Now we should connect for A pin number A, 9th pin, input A, 10th pin, input B, 11th pin, input. So A, B. Now it's taken from 5 input pin connected. So 9 pin, 10 pin, 11 pin inputs, and D for IC 8:1 multiplexer. I will check it. Switch on the trainer key. Okay. Now check the output Y. 6, 7, 10, 14. We should get output. Remaining all we need to get. So I am checking for this is 0, 1. Okay. Now 2 output should be high. Okay. Next 3 output should be low output. Next 4 output should be 1. 5 output should be 1. Next 6 output should be low. For 7 it should be high. Low. 9 low. Okay. For 10 it should be high. Next, for all combinations it should be low, and for only 40 high. That means this is how multiplexer, and check the. Thanks for share and subscribe. To design using NAND gate. Two types of NAND. 2 input NAND gate 400, input NAND gate 10. 2 input NAND gate is same as AND gate connection, that is pin number 1 and 2 are the inputs. Go on like that, but 3 input NAND gate pin number 1, 2 and 13 are the inputs, and pin number 12 is the output for first NAND gate. Same as 3, 4, 5 are the inputs, and 6th pin is the second NAND gate. And 11, 10, 9 are the inputs, and 8 IC configuration. Now we'll see how to design the JK master slave flip flop. This is pin number IC 7410. These are all 14 pin ICs. 10 2 ICs. For this 2 3 input NAND gates, only one IC is 0. Placing here. And for inverting the clock, I am using okay. Now it's not get the pin, that is 16 pin. Slots are empty. 8 and 9 were not used. 7 found it. And then here the clock input. Okay. That is monopulse 1 heads. The inverted that is pin number 2 not get, and give the inverted clock for and get pin number 2 and pin number 4 in between that. That is pin number 2 and 4. Connect it. Okay, this clock, inverted clock, pin number 2 and pin number 4. Clock clock pin number 3 and 3. Pin number same clock is again applied for pin number 13 of first IC. Next input, that is J, pin number 2. Give the input J. Next time is pin number 4, input J. Now 1 for 10, pin number 1, 2 is 10, 12, because it is C. Pin number 4, pin number 5 and pin number 14. Like pin number, that is pin 14, 3 input AND gate is given for the next 3 input AND gate. Pin number 2. From pin number 1 of second IC is taken as set. Number IC is given for 6, 13 is given pin number IC. Number 12 is given as 3. 12 means 14. Pin number 3 for the same IC. And from pin number 5 it is taken as, so I'll get and preset clear somewhere else. Preset clear. A 6 get out the pin and for is mark out given as that is for that is same as 6 is for the number put output input to get that is 10. Okay, next number output for the AND get 9. Okay, 10, 11, pin 12 is given of 8, that is given for here 30. Next NAND gate output pin number 8, pin number 12, one of them pin numbers of 2 input is 15. Output 7. Pin number is that the output that is 10 out. At the 9th pin and pin is this is the once worker will be clock. You should reset these two or preset and clear on one. Use now true test preset use inactive, that is 0. Clock is applied. Change. This bar is changing the input. Okay, applying. Now reset and Q bar. Now change the input values. J1 K is it will that is 1 J and by the remain stage 1 0 to check the output for the J and Q. To demonstrate design by code can be 7th example. 1 by showing it as B2. In this, the gray is using XOR. That is first bit keep as it is 1 is same or put again put gray G2 for the and IC using 74C. This is gate 14 pin IC and 743C. This is the OR gate pin output from same as 6th pin output and 7 pin should and 14th pin should be given VCC. Next, when coming part of IC 9 and 10 becomes will be the output. 12 that is pin same and 4 6 output, 7th ground, 10 input and 8th output, 12 11 output and not gate only we are giving one output getting input, 3rd pin input, 4th pin output. Likewise you can connect 6 NOT gates in big ground and 14 pin. This is the circuit for binary. We are 4-bit netted. Use and gray one. Now we'll see how to. I am using number IC that is 14 for the NOT gate. Can. This is the 7408 notch. Connect this. Okay, close to pins were not as this is used for not and using some place here close and I for 04 here for using 32. See the circuit that is B3. Okay, now the connection is and second to for and gate the second 1 2 and third and second next. Okay, this as here and get connections from the inverted of first node connecting B2 input, B2 inputs connected and fourth AND gate. From this we need to take two tapping probes. First AND gate input, first AND gate, one of the input, next one fourth AND gate, that is fourth AND gate input, either 14 pin or 15 pin. Okay, now taking the inverted of B2, that is second AND gate input as well third AND gate. So from this node second AND gate input and again one more connect and third AND gate input. Now first AND gate and second AND gate outputs were connected, that is first AND gate and second AND gate outputs were connected for OR gate 1, 2 and that output OR gate output is taken as G2. Okay, for all ICs don't forget to connect the 7th pin ground and 14th pin CSE. Okay, connect all the 7 pins for ground and 14th pin for VCC. Now we'll connect the remaining B1 and B2 as same. So now the connections were completed according to the circuit design. Now I'll switch on the trainer kit and we'll check the output according to the truth table. Okay, now randomly we'll check one. Okay, for 0, 0, 0, 0, 0, 0, 0, 0, 1, same 0, 0, 1 and 0, 0, 1, 0, the output becomes 0, 0, 1, 1. 0, 0, 1, 1, it should be 0, 0, 1, 0, 0, 0, 1, 0. Next 0, 1, 0, 0, the output should be 1, 0, 0, 1, 1, 1. Okay. Next 0, 1, 0, 1, 0, 1, 1, 1. I'll check the last one, all ones. We need to get 1, 0, 0, 1. Yes, according to truth table, the design circuit is working properly. Thanks for watching. Please do subscribe and share the video. Myself Ushashri. Now I am going to demonstrate how to design gray code to binary conversion circuit hardware, that is program number 8. Okay, this is the truth table, that is how this truth table is constructed. I'll give one example. Take an example, any one value, that is 0, 1, 0, 1. First keep the first bit as it is and do the exclusive OR operation on these 2 bits. So exclusive OR operation will get 1. Again exclusive OR, so same 0. Again 0, 0, same, so 0. This is the 1, 1, 0, 0 binary. Gray code is taken and converted into binary code. This is how the truth table for all the combinational values 0 to 14 is taken as a truth table. And by this, okay, using this and minimizing using K-map, the circuit is designed like this. This is the circuit design after minimizing by using K-map. Now I will design this circuit and show you the output. We need 4 ICs, that is 1 IC not IC and 2 ICs, that is AND gate IC, and 1 is OR gate IC. Right? 7404 is connected here and 740808 here, and this is the OR gate 7432. I am doing the connections according to the circuit. So I am considering from this side B3, B2, B1, B0 as inputs, same Z3, Z2, Z1, Z0 as outputs. G3, okay, G, gray code to binary conversion, G3 I am taking as input and given for NOT gate input. And what are all the connections for this is, okay, according to the circuit, directly Z3 input becomes the B3 output. And one more connection, that is for second AND gate. This is connected for second AND gate, that is pin number 4. Now from G3 input connections were completed. So I am taking the connections from G, that is NOT gate output. Pin number, what are all the connections is first pin number 1, and that's it. Now I'll take input, that is for NOT, and what are all 3 AND gate input. So this is given G3 first AND gate input, and the output of first AND gate is taken as an input of OR gate, that is the last connected, okay, and that same G3 input is completed. Now G2 NOT gate output, that is connected for second AND gate input, that is pin number 5, okay, that's it, only one connection. Now this AND gate output is given as an input, one of the input for OR gate. That OR gate output is taken as an B2, binary 2. Next, and same this OR gate output, okay, is connected for NOT gate input, and this NOT gate output is given for AND gate input. Next input is pin number. Again the same OR gate output is given for one of the AND gate, that is pin number 9. Okay. Same gate given for one input. So 4 AND gate connection input. Okay, now taking one more input, that is G3, and connecting to the pin number 9, that is NOT gate input, and that is G1, sorry, Z1. Z1, what are all the connections? That is AND gate, one input AND gate. The same input is given for one of the AND gate, already NOT gate of this NOT gate board. Now AND gate output is given new OR gate from now output, that is taken and it or AND gate. This means AND gate input. This is the code, and that AND gate output is given for OR gate. Okay, and this output is B1 output, and the same is given for NOT gate, and that inverted output is given for new AND gate input, new AND gate, and the output of OR gate is taken and given for one more new gate input. And now taking last input Z0 input and connecting to the NOT gate input, and for this we'll check the connections. That is only one connection for the OR gate input. So I'll one connection from the NOT gate input. It is given for OR gate AND gate input, and input. And this inverted output is given for another two inputs from pin 11 and given for gate input, that is 9, that is B. Now all the 40 CC 7th pin for ground. Switch on the trainer, check the output. According to the table, all zeros it should be 0, 1 it should be 1, next 1 0 it should be 1 1, 1 1 it should be 0 0 1 0, 1 1 0 it should be 0 1 1 1, 1 1 1 0, 3 1 0 1 0 1, 1 0 all ones, 0 0 1 1 0, 1 1 1 1 0 0 0, next 0 1 b 1 0, it should 0 1 it should be 1 0 it should 1 1 1. This is design and put. Thanks for watching. Subscribe. I am going synchronous counter part B. 6 according more should count from 0 1 2 and then I start with 0 0 0 value. Or when it means display 0 0. And of the here we have 7 4 C by using we two flops, these two as one we can connect to JK flip flop using only one flop. For this okay we are 0. Okay, now design the see the notch the and 6. This is 16. Again notch 7 4. Okay, give the 7th pin ground connection. For 14, this is 14 pin IC, 16 pin, 14 pin. Here two notches the line. So that to this circuit I lock heads pin number 1, number 6. And again second for first IC and pin number that is connect for edge. This all connected for one head. This right. This pin number is IC that is this is pin number first 4 and next pin you have to give high, you can give second IC connect pin okay, for the high input. And next we'll see preset. Here is pin number 3, 8 and 3. 8 of first IC well. This number 3 connected input high. This is a high. Okay. Okay, given for clear. I'll connect set. Preset is 7. Pin number 2 of first IT as of and again pin number 2 of second IC. Pin number 2 and 7 and again 2 for second IC. These three were connected as a preset. Okay, connect for preset. Now take the 15th pin as the output. 15th pin output QA bar. QA. Okay, same from that 15th pin tap and connect for 1 and get input and get input. Again tap and connect, give for the second IC JB, that is input 9, that means same IC pin number 9, and again it is given for KB, the same pin number, same IC pin number 12, pin number 12, tap this same. Okay, next second IC output is from pin number 11, pin number 11, and give it to the AND gate, second pin input. Next same pin number 11, tap one more and take it as output QB. Now connect C on number, that is the output QC, and QC bar, that is pin number 14, already it is given, that is pin number 4, feedback as a input of JA. This completes the circuit design. Now we'll switch on the circuit and check the output. And check the, is always preset and clear should be high. See, first 0, 1, 2, 3, 4 returns to 0. Okay, this is how to check the output for synchronous modifier. Thank you.
Today I am going to design the circuit mod 6 asynchronous counter part B 9th experiment. Actually this is by using 7 segment, but I am doing by using bits, output bits. For this we are using 7490 IC. Okay. So this notch, connect this upside. This is 14 pin IC. So leave down 2 pins and connect this. This is the circuit diagram. According to this circuit, now we need to give the clock input, that is for 14th pin. So I am connecting 14th pin, means here we are leaving 2 pins. So it becomes 16th pin. 16th pin clock, that is monopulse high. And this is 1 Hz. Monopulse is given 1 Hz. Next, pin number 1 is connected for pin number 12 and it is taken as QA. Connect pin number 1 and connect it for pin number 12, that means 14th pin, and it is taken as output QA. So this is QA output pin. See here, this is the logic outputs, so you need to connect output pin. Okay, connect this QA this side. Next QB. Okay, see this QB is connected from 9th pin. 9th pin is connected as QB. Next 8th pin is connected as QC. 11th pin is connected as QD. 8, 9, 10, 11th pin. Okay, these are all the outputs. Now we need to connect 2, 3, 6, 7, 10 to ground. So pin number 2, pin number 3, pin number 6, pin number 7 and pin number 10, 8, 9, 10. All are tapped and connected to ground. Okay. All the pins 2, 3, 6, 7, 10 tapped and given for. This is what the circuit design. Now finally pin number 5 for VCC. So pin number 5, connect VCC. Now turn on the trainer kit. Okay, and see here, look at here, all zeros. Now I'll give the pulse input. Pulse 1, output is 1. Next again I'll give one more pulse, 2. Next again I'm applying the pulse, output 3. Again applied one more pulse, count, that is 4. Up to which count? This is designing mod 6. So 0 to 5. See, again I am applying clock pulse, mono pulse 5 and then returning to 0. 1, 2, 3, 4, 5 to 0. This is the mod 6 design. Thanks for watching. Please do subscribe and click the bell icon. Share this video. Thank you.
Myself Ushashri demonstrate execute half adder hardware circuit taking AB input value 0011 and sum and carry. When you bit will get 0 output, 01 bit high the I, and when you add 1 with 0, 1 and carry is 0. When you add 1 1, the sum with 0 1. This is what when sum, and for this high outputs, okay, expression for sum is equal to, okay, here 1 means here A is 0, B 1, so A bar B plus A1 B 0, so A B bar, 0 means B bar. Now same as we'll write the expression for carry, that is only one output, so that is A B is equal to 1, so directly expression. When you design the connecting to NOT gate, okay, now A bar B, take inverted output of A to AND gate input, same as B directly input. So these are all the two inputs and output is taken. Next A B bar connected for AND and these two outputs were connected for OR gate. This becomes sum. And coming to carry, A and B connected for AND gate and carry will be obtained. Now we'll see the pin diagram for NOT gate. 7404 IC is used as NOT gate IC. Okay, here we can connect 6 NOT gates. For each and every 14 pin IC, we need to connect 7th pin to ground as well 14th pin for VCC. Now first pin is input and second pin is output. Go on, you can connect 6 NOT gates. Same as 7408 IC. First 1 and 2 pins are the input and the third pin is output. Same as here we can connect 4 AND gates. Coming to OR gate, 7432 IC. Okay, first 1 and 2 pins are input and the third pin becomes the output. Go on like that again, you can connect 4 OR gates using 7432 IC. Okay, now I am taking 7404 IC and placing here, so it works not gate can be connected. Now 7408 IC, this is used as, and 7432 IC for OR according to the set. First A input and given to first pin of NOT gate, and this A is connected for gate first input, same A is connected for second AND gate, that means 1 2 3 fourth pin, and next A tapping a probe, connect it for third AND gate first pin, that is third AND gate, seventh pin, eighth pin becomes output, so ninth pin. Now take the output of NOT gate, that is A bar for AND gate first pin, pin number 1, and set A is given. Connect one, give NOT gate IC, and this B is connected first, and the same is connected to first. Again the same B is the third AND gate, Okay, this is 11 12 inputs. Now take the inverted output, that is from NOT gate, that is fourth pin, and connect it for the second AND gate second input, that is pin number 5. Okay, now AND gate, first AND gate output is given input, means pin number output given for OR gate for one input, and AND gate number 6 second input for OR gate, that is pin number 2. And now the 3 is sum, and same as get third and gate, that is pin number 8 is taken as output carry. Now connect all the 7 pins to ground. Okay, connecting all the 7 pins, 7th pin of each to, that means 14, because it is 14 pin. So here 6 are empty, that means 9 pin or not. So 16th pin connected VCC plus 5 volts. Good. Okay, switch on the trainer key. Now we will check the truth table. That is for 0 0. Sum 0 carry 0. For 0 0 input, sum 0 carry 0. Now give 1 for that is A B 0 1. Will get sum 1 carry 0. Sum 1 carry 0. Next A1 output sum and carry, both inputs are 1. Sum 0 1 0 0. Watching, please and share. Now straight hardware part, that is 4th B experiment. Okay. AB 0 1 fraction, that is from 0 0, the difference 0 and borrow 0. Subtract 1 from the difference becomes, and borrow is 1. Next, when you subtract 1 from 0, difference becomes 1 and borrow is 0. Now when you subtract 1, the difference is 1, sorry 0, and borrow 0. Okay. Now design the circuit, that is wherever 1, so different circuit is now difference is equal to, okay, A bar B plus A same as borrow is equal to, that is A bar 1, that will get output high that is A bar B. Now we'll design this not gate for bar and gate or gate. First A bar, take one input A bar, B or AND gate. That is 1 and 3. Same as A B bar. And other input B bar, not get out. This is not pin number 1, pin number 2, pin number 1, pin number 2. Okay. Take here 4, 5, 6 ground. Next borrow 2 for gate, that is pin number 1, and take this from first pin A bar and next, that is already 4 5 becomes 9, and now this where by using not gate 7 4 7 4 or gate 2. These are all the, now I am connecting. Not gate IC 7404, 7408. See the notch is upside, notch. Okay, connect this. Notch is upside. Connect this here and see for all pins 2 slots were empty. Now pins, that is 7 is ground, pin VCC because were empty, 9th pin negligible ring, after 7th pin the pin, okay, and ground. Circuit in that is taken, it is for gate from this and pin for and gate 4th pin. So from completed, that means pin of not gate converted output, and that is number 1, okay, and next pin number 9 and gate pin number this become. Next one, take the B and connect it for third pin, and from this and get second and get 10th pin and get second pin and for next in next and set, that means output, and number 5 connect gate can get output for OR. This pin and gate pin number 1 OR gate and pin number output as in gate pin number put OR gate pin number taken as output of third AND gate, that is pin number 8 taken as 0. Switch circuit the that is 0. Difference is 1 and borrow is next for difference 1 0. Okay, the 1 both inputs 1 0. This video subscribe myself Ushashri. Now I am going to design full circuit. Part B, this is the, that is when you take the 3 bit sum by sum, and now I will according to the sum and carry. Okay, circuit. Now I am going to for this gate, that is 4 and 2 hours from connect 4 and from connect, and here or 2 or targets 3 to I going to 1408 3 2 and 0 and A for A is that same for and pin number 1 for is the IC you take and same for the IC 7408 connection for third and number left. Okay, output of not and connect it for first gate and gate in, and no other one more input that connected third pin connections check and in. Same B input is and gate for connections, that is for inputs and 2 and gate ICs. Again connecting 2 more inputs connected for gate of IC, fourth pin of AND gate. Take the NOT gate and check the connections, that is AND gate pin other connections. The that is C for NOT gate and check the C for the AND gate of first IC. So that is fifth pin is given for next. Again that is C is connected for second IC of second AND gate and third AND gate. Again C is connected for second IC of second AND gate and third AND gate. Third AND gate. In that Now output, that is C bar from the of C, and that is third AND gate, that is pin number 9 of AND IC from C from now inputs inverted in all ICs pin VCC, 7th pin and 14th to VCC, 7th pin, 14th VCC. We'll connect just or gate. This is okay. First AND gate given for is the 6th pin is given put 1 and 2 OR gate. Output is given the 4th input. And one more, the same is given NOT gate inverted output, that means pin number 9 is and output NOT. This is 4th pin of pin number. Now the third AND gate, 4th AND gate output OR gate. I am taking OR gate, the 4th and given for the inputs out and as sum. Next here IC, okay, second and for third pin on AND gate, and second IC is taken output and given for OR gate inputs, that is 9, 10 pin numbers, and 8 is taken as output and given as an input for the OR gate. And one more AND gate, new AND gate output, that is taken and given as an input OR gate. Output of this OR gate is considered as circuit completed. Now switch on the trainer kit truth table. For 3 inputs 0 and carry is 0. For now this is C sum row. 0 1 0 carry 1. 1 0 0, that is carry 0. 1 0 1 sum 0 carry 1. 1 1 0 sum 0 carry 1. All input ones, sum 1 carry 1. This is how to check the output watching my video. Please do subscribe and share my video. Shri demonstrate how to design full subtractor hardware and part B. Under that D. Say this is the truth table for full subtractor. Okay, 3 inputs A, B, C, and what will be the difference and borrow. Okay, according to this truth table, wherever the ones, that difference expression and ones for borrow becomes the, okay, by using this expressions, this is the diagram. Actually this circuit is the same full, see there, this is adder circuit, full subtractor circuit. The circuit design and the expression is difference, and you check the carry the expression connecting A whole adder. It should from A. Expression I am showing. See, for sum A exclusive or B into C bar exclusive or B whole bar into C. Same is for difference. Come to carry A plus CA. But when you borrow in full sum A bar C, A is changing to A bar as well A, that A bar B. Okay, here wherever A is there and BC is constant. BC is constant. CA, CA, RC instead of A, A, B. So I'll just change this connection that is from full adder. I'll change to full subtractor where I have given A input for AND gates. I'll change to A bar so that both the outputs. Now we'll check the full adder circuit. Already this is, I have shown this full circuit designing in previous video. Please watch that video. Just change these two connections. Look at this already designed. I'm trainer. I'll show the put, that is truth table 1 1 0 0 1. You check 1, it should be okay. This changes random output, that is 1. See here 0 1. Okay, 0 1. Change adder to subtractor. Just that carry. Okay, that means A I'll give instead of A input, I'll change that A bar and I'll show the truth table for full subtractor. See here. For AND gate, first gate, okay, it is connected to A. For first not A, I'll connect not gate out number 2 in AND gate. Okay, this is okay. This AND gate A, I'm changing A bar. This no need to connections. Inputs you have A from A bar. That's it. Enough. Now check the switch on the trainer kit. Now check the truth table. from the truth for 0 0 0 difference 0. Next for 1 borrow 1 for 1 difference 1 for 0 borrow 1 for 0 1 difference 1 0 borrow 0 for 0 differ 0. That's it. Very simple, just shift of A to input the for watching. Please do subscribe video. Myself Pushashri. Now I am going to demonstrate 8:1 multiplex program at B for VTU. Please do subscribe to my channel and click share this video. For this we need multiplexer IC, that is 7-4 IC. Okay, consists of 3 selecting, means 8 1 and 1 enable. For this we need now design input ABCD. The x y is equal to f summary expression 2 4 and 10 for this y output high, meaning okay, this. Now we are entering the way. See here 0 1 we should get 1 for 1 10. The output should be high, meaning low. Now this is the y output. Now we will enter with this method the for e as well as now. Okay, this is the rules for enter K-map using MEV method. Okay, the 2 1 0, the 0 should enter value, this value is enter 1 values, so the value MEV entered. This is inverse 1 0, enter the inverted value r using don't care 0 don't care 0, so 0. Next here 1 don't care, so it is 0 0 1 1 don't care 1 0 don't care 1 1, it should be entered 1. Now using this MEV K map we are entering here the values, that is 0 0 1 0. This combination it is 0, so you should enter 0. Okay, now 0 1 1 0 inverted values, so D bar. Because this is inverted, 0 becoming 1, 1 becoming 0. So it is entered D bar. Next, so these two values 0 input same, so you should enter D, same value D. Next, here 0 0, so take it, enter value 0. Now inverted values 0 1 and changing 1 to 0, so inverted D bar. Here 0 0, so you should enter 0. Inverted values again D bar. Okay, so these are all the data lines D0, D1, D2, D3, D4, D5, D6, D7. Okay, this should be given for multiplexer IC data lines input. Okay, now we'll design the circuit using this designing. Now designing the 8:1 multiplexer, we need one NOT gate IC, that is 7-4. See the notch here and lock. Next multiplexer IC, this is 74151, notch upside, place here. Okay, lock this. Now according to the circuit design, first we need to give the D input. I am taking here D. Input is connected for NOT gate first pin, and the same input, see the circuit diagram, the same data input is given for pin number 1. 1 means that is pin number 1, data line 2. See here data line 2. In this data line 2 is 1. So we are connecting. Okay, according to the MEV, see this D, that is the same input D is applied for D3. D3 is pin number, D3 pin number 1. Okay, D3 is pin number 1. So I am connecting to pin number 1. Next coming to D bar, that is inverted output taking from NOT gate. Okay, D1, D5 as well D7. So connections connect for pin number 3, pin number 14 and pin number 12. Okay, so D bar is connected. Now we'll see 1 MEV input is for D2. D2 is pin number 2. 1 is for VCC. VCC, so pin number 2. As well, for all ICs, you should connect 16 pin VCC or 14 pin IC is VCC, because 14 pin here 2 slots were, so 8 and 9 pins are not considered. So this becomes 16 becomes 14 for 14 pin IC. So connect VCC, and then 7th pin ground for all ICs, 14 pin ICs. If suppose it is 16 pin IC, 8 grounded. Okay. Now we should connect next remaining pins 0, D naught, that is data input 0, 0 and for 0, D6 zeros should be 0. That is pin number pin number 4. Pin number 7 is enable. Pin number 15 enable, we are considering 0. Next pin number, okay, pin number 50, pin number 4 are the here 0 and 6 enable, it should be again 0. So all should be given for 0 means good. We should connect for pin A, 10th pin, 11th pin, A, B, C, D were connected. Output is taken from 5. So 9th pin, 10th pin 11 pin inputs, and D input as well not is given for input for IC 8:1 multiplexer. Output 5th. The switch on the trainer cable. Now values 2 and 10 should get out, and for mean low, so this is 0. 2 should be next, should be low. Next output 5 output should be 1. Next 6 output should be low. For 7 it should be high. 8 low. 9 low. Okay, for 10 it should be high. Next, for all combinations it should be low, and for only 14 it should be high. That means this is the 14 high. Okay, this is how to design the 8:1 multiplexer output. Thanks for watching. Please share my video and subscribe. Thank you. Now I am going to design JK master slave flip flop using NAND gate. Here we are using two types of NAND gates, that is 2 input NAND gate IC 7400 and 3 input NAND gate IC 7410. Okay, 2 input NAND gate is same as AND gate connections, that is pin number 1 and 2 are the inputs, 3 is the output. Go on like that. By 3 input NAND gate, 1 13 or and pin number for gate, 3 4 5 and output for gate, and 10 inputs and output. IC configuration. How to design this I 740 14 pin 0 is 2 gates, and for this only 4 zeros placing here. Converting the clock, I am using NOT gate. Okay, now first for this NOT gate, connect that 14th pin, that is 16 pin, 2 slots are empty, 8 and 9 were not used. 7th pin, ground it. Clock input. Okay, that is monopulse 1 heads. This again inverted, take this inverted, that is pin number 2 NOT gate, and give the input AND gate pin number 2 and pin number 4 in between that. That is pin number 2 and 4, connect it. Okay, clock is given for pin number 2 and pin number 4. Clock that is for, and pin number. Clock is again applied for number of first IC. Next, input A, give the J. Next same as input number J. Connect pin number 1. 2 input and get 10. 10 means here because it is 4. Next number 5 given number pin 2 input and get 12. Pin number 12 means 14. Next pin number, that is pin number 12 means 14 of 3 input and gate is given for the next 3 input and gate 2. Number 1 of second is taken as preset. And next pin number 16 or the same number given as 14 as 3 for the same IC, and from pin number 5 it is taken as clear. So I'll take JK and preset clear somewhere else. Okay, preset clear. Pin number 6 of first AND gate, that is NAND gate output 6 is given as input of the second AND gate 4. Now connect 16th pin for VCC, that is 14th pin, and 7th pin for ground, 7th pin, 14th pin VCC. So this AND gate, that is master, is completed. Now we'll see the slave. Master NAND gate, that is second NAND gate 12, pin number 12 output is given as input, that is 12 means 14, input for the NAND gate, that is 2 input NAND gate. Same as 6, pin number 6, output given as put for NAND gate. The 2 input NAND gate output, input of next AND gate, that is pin number 10. 10 means 12. 10 means 12. Okay. Next pin number, again pin number 3, that is output, is taken and connected for the NAND gate, next NAND gate. Pin number okay. 10 from 2 means 12 is given for 3 and NAND gate, that is given for 11. 11 means here 13. Next NAND gate output, pin number 8. Pin number 8 means 10 is given for pin number 12, that is 14. Already one of the input is given from 3 input 5th pin. Next pin number 6, that is output of the 2 input NAND gate, is given as an input, that is 13. 13 means 15. 2 input NAND gate. Next output, that is pin number 11. 11 means again the same. Pin number 11 means 13 is given, that is Q bar. Here connect the output Q bar. Now pin number 8, that is pin number 10. From pin number 10 take the output Q. Now connect the 14th pin VCC and the 7th pin is ground. This is the circuit design. Now when you apply the clock, that is once it will be working, master will be working when you give the positive clock, and again if you give the clock pulse, that is negative, slave will be working. Always you should set that preset and clear 1 1 and inputs. Now switch on the trainer kit and check the truth table. Always preset and clear should be 1 1 high. Okay. Now we'll see here J, K 0 values, so slave will be inactive. So it won't change. Okay. When we apply, that is clock, when we apply clock, see here clock like 0 0, it will be in the same change, 0 1, that is Q is 0 1. Put K in the clock. Now see the reasons Q 0 1. Now use K 0 the, now that comes 0. Now again put J and K 1 1 and apply, it remains state and Q. This truth table for the master slave J and Q.
Shri, now I read how to do binary code conversion. Part B, 7th experiment. Now take an example, any binary value, that is 1 I am taking, naming it B1, B2, B3. Okay. In this, how we are converting this binary to XOR operation. First bit it is, and do this 2 bits, so the output is 0. Again exclusive OR with this 2, that is 0 1, so the value is output 1. Again 0 1, the 1y. This is the gray code, G3, G2, Z1, Z0. For IC 7408 2-bit and IC, this is 14 pin IC, and we are using 7404 IC. This is used for NOT gate, 14 pin IC, and 7432 IC. This is 14 pin IC, OR gate input. In this, first pin input, second pin input, output same as 4 inputs, 6 as out pin IC, 7th pin should be ground and 14th pin should be given VCC. Next, when coming to next part of IC, that is 9 and 10 becomes inputs and 8 will be the output. Same as 12, 13 inputs and 11th pin is output. Same for all the ICs, that is 17, 14 pin OR gate also same. 1, 2 input and 3 is output. 4, 5 input, 6 output, 7th ground, 9, 10 inputs and 8th output, 12, 13 input, 11 output and 14 pin should be output. For NOT gate, only we are giving one input and inverted output getting. So first pin input, second pin output, third pin input, fourth pin output. Likewise, you can connect 6 NOT gates in one IC. 7th pin always should be ground and 14th pin will be VCC. This is the circuit for binary to gray code. Okay. See here we are using for 4-bit inputs B0 NOT gates are connected, and for this using AND gates and OR gates, getting the Z0, Z1, Z2, Z3. Now we'll see how to connect. Here for NOT gate I am using the pin number IC, that is 14 pin 7408 IC NOT gate. This is the 7408 and see the notch. Connect this. Okay, close. Two pins were not connected. So as this is used for NOT gate, and for AND gate we are using 7404. Place here, and again this is also for AND gate 4. Next for OR gate we are using 7432. Now we'll see the connections according to the circuit diagram. Okay, according to this circuit now I am designing, that is B3. Okay, given for NOT gate input pin number 1, and pin number 1 what are all the connections required, that is G3 output and second AND gate input, giving one connection to G3. Okay, tapping here, and one more tapping for AND gate, that is first AND gate 1, 2 and third AND gate third pin, second AND gate. Next output of NOT gate, okay, that is second pin of this is taken as here. This is connected for AND gate first pin. Next, no connections from the inverted of first NOT gate. Next, connect B2 input, what are all the inputs connected, and gate. Two probes, first AND gate in and one of input of 50. Okay, now inverted of B2, that is second AND gate input, third AND gate. So from this NOT, second AND gate input, and again one more and third AND gate, third AND gate. For second AND connected, next AND gate, second AND gate outputs were connected. OR gate 1, output is, and for don't for 7th pin ground and 14th pin VCC. Okay, connect all the 7 pins for ground and 14th pin for VCC. Now we'll connect the remaining B1 and same. So now the connections were completed according to the circuit design. Now I'll switch on the trainer kit and we'll check the output according to the truth table. Okay, now randomly we'll check one. Okay, for 0 0 0 0 0 0 0 0 1 same 0 0 1 and 0 0 1 0, the output becomes 0 0 1 1. 0 0 1 1, it should be 0 0 1 0 0 0 1 0. Next 0 1 0 0, the output should be 1 0 0 1 1 1. Okay, next 0 1 0 1 0 1 1 1. I'll check the last one, all ones. We need to get 1 0 0 1. Yes, according to truth table, the design circuit is working properly. Thanks for watching. Please do subscribe and share the video.
Myself Ushashri. Now I am going to demonstrate how to design gray code to binary conversion circuit hardware, that is program number 8. Okay, this is the truth table, that is how this truth table is constructed. I'll give one example. Take an example, any one value, that is 0101. First keep the first bit as it is and do the exclusive OR operation on these two bits. So exclusive OR operation will get 1. Next or 0, again 0 0 1 1 0 0 binary. Gray code is taken and converted into binary code. This is how the truth table for all the combinational values 0 to 14 is taken as a truth table. And by this, okay, using this and minimizing using K-map, the circuit is designed like this. This is the circuit design after minimizing by using K-map. Now I will design this circuit and show you the output. We need 4 ICs, that is 1 IC not IC and 2 ICs, that is AND gate IC and 1 is OR gate IC. Okay, so not gate 7404 is connected here and 708 is the OR gate. So I am doing the connections according to the circuit. I am considering from this side B1 B0 as inputs, same Z3 Z2 Z1 Z0 as outputs, G3. Okay, G gray code to binary conversion G3 I am taking as input and given for NOT gate input. All the connections for this is, okay, according to the circuit, directly Z3 input becomes the B3 output and one more connection, that is for second AND gate. This is connected for second AND gate, that is pin number 4. Now from G3 input connections were completed. So I am taking the connections from inverted G, that is NOT gate output. Pin number 2 to what are all the connections is, first pin number 1 AND gate, first AND gate input. That's it, completed. Now I'll take next input, that is G2. G2 is given for pin number 3 NOT gate and what are all the connected, that is for Z3 first AND gate input. So this is given G3 first AND gate input and the output of first AND gate is taken as an input of OR gate, that is the last connected. Okay, and that same G3 input is completed. Now G2 NOT gate connected for and gate input, that is pin number 5. Okay, connection. This output and input for OR, that OR gate output is taken as an B2 binary 2. Next, and same this OR gate output, okay, is connected for NOT gate input, and this NOT gate for input, that is input 9. Again the gate is one of the, that is pin number. Okay, the same OR gate output again given for one more AND gate input. So I am taking the fourth AND gate connection input. Okay, now taking one more input, that is G3, and connecting to the pin number, that is NOT, and that is Z1. What are all the connections? That is AND gate, one input for AND gate. The same input is given for one of the AND gate, that is already NOT gate of this is given. This is the NOT gate. So one more input. Now this AND gate output is given for new OR gate input. Only one connection from G1. Now G1 inverted output, that is NOT gate output, is taken and it is connected for AND gate. This means AND gate input. This is the AND gate input, and that AND gate output is given for OR gate input. Okay, and this OR gate output is taken as B1 output pin output, and the same is given for NOT gate, and that inverted output is given for new AND gate input, new AND gate, and the same output of OR gate is taken and given for one more new AND gate input. And now taking the last input gray Z0 input and connecting to the NOT gate input, and for this we will check the connections. That is only one connection for the OR gate input. So I will connect one connection from the NOT gate input, and it is given for AND gate input, and this inverted output is given for another AND gate. Now AND gate, two AND gate outputs were taken from pin number 8, 11 and given for OR gate inputs, that is pin number 9 and 10, and this output, that is 8th pin, taken as B0 output. Now connect all the ICs for VCC and 8 for ground. Switch on the trainer kit and check the output. According to the table, all zeros it should be 0, 1 it should be 1. Next 1 0 it should be 1 1. 1 1 it should be 0 0 1 0. 1 1 0 it should be 0 1 1 1. 0 1 1 1. 0 1 0 1 1 0. 3 ones 0 3 ones 0 1 0 1. 1 0 0 0 it should be all ones. Next 1 0 0 1 1 1 1 0. 1 1 1 0. 1 0 1 0 1 1 0 0. 1 0 1 0 1 1 0 0. Next 1 0 1 1 it should be 1 1 0 1. 1 1 0 1. 1 1 0 0 that is for it should be 1 0 0 0. 1 1 0 1 it should be 1 0 0 1. 3 ones 0 it should be 1 0 1 1. All ones it should be 1 0 1 0. This is the circuit design and output truth table. Thanks for watching. Please do subscribe and share my video.
Today I am going to design the synchronous mod 5 counter hardware part B 6th program. According to this truth table, mod 5 means it should count starting from 0 to 4. 0, 1, 2, 3, 4 and then again it should start with 0, 0, 0. That is the count value. 0 to 4 and then when count is 5 that means it should display 0, 0, 0. This is the design of the circuit. Here we are using 7476 IC. That is, by using this IC we can connect flip-flops, these two, and same as one more flip-flop again we can connect two JK flip-flops, but we are using only one JK flip-flop. And for this AND gate, okay, we are using 7408 IC. Okay, now I will show how to design the circuit. Check the notch and place the 7476 IC. This is 16 pin IC. Notch and place the 47 AND gate. Now for this AND gate, first give the 7th pin ground connection and then for 14, this is 14 pin IC, 16th pin becomes the 14 pin. Here two notches were that is 8 and 9 were not activated. No need to and now your okay, that is clock 1 head, pin number 1, pin number for the second 74 IC 1, for first IC 1 and pin number 6. This is give for input, that is monopulse high, connect for 1 hedge. These all pins were connected for 1 heads. This clock is applied. Clock is applied 1 heads.
Now design the circuit, that is pin number 4 is connected for the second IC, pin number 14, that is QC bar. This is pin number 14 for pin number first IC 4. And next pin number 60, 6 to give the nothing but you can give. Again you connect 16th pin high, okay, because these two are the high inputs given. And next we'll see preset clear. Clear is pin number 3, 8 and 3. Pin number 3 and pin number 8 of first IC as well the second IC pin number 3 were connected to input, that is high. Again this is high, clear, high. Okay, given for clear. I'll connect preset. Preset is pin number 2, 7. Pin number 2 of first IC same as pin number 7 of first IC. And again pin number 2 of second IC. Pin number 2 of first IC as well 7 of first IC and again 2 for second IC. These three were connected as a preset. Okay, connect for preset. Now take the 15th pin as the output. 15th pin output QA bar. Okay, same from that 15th pin, tap and connect for one and get input. Again connect the second JB, that is number 9. That means here itself in the IC pin number 9. And again it is given the same 12 same. Second IC is from pin number 11. And the pin input. The same pin number 11, tap one more and take it as output QB. Now connect second IC of pin number 15, that is the output QC. And QC bar, that is pin number 14, already it is given, that is pin number 4, feedback as a input of JA. This completes the circuit design. Now we'll switch on the circuit and output and check the preset high. First 0, 1, 2, 3, 4 returns to 0. Okay, this is how to check the output for synchronous mod 5 up counter using 7476 IC. Thank you.
Myself, I am going to design the circuit mod 6 asynchronous counter, part B 9th experiment. I think 7 segment, but I am bits, output bits. This we are using 7490 IC. Okay. See this notch, connect this upside. This is 14 pin IC, so leave down 2 pins, connect this. This is the circuit diagram. According to this circuit, now we need to give the clock input, that is for 14th. Means here we, so it becomes 16th pin. 16th pin monopulse high, and one is 1. Next, pin number 1 for pin number 12 and as QA 1, and connect it for pin number 12, 14th and it is taken as output. So this is QA output pin. See here, this is the logic outputs, so you need to pin. Okay, connect this QA this side. QB is connected with the pin 8 as QB. Next, 8 is C. 11th pin is connected as QD. 8, 9, 10, 11. Okay, these are all the outputs. Now we need to connect ten to ground. 3 pin and 8, 9, 10 all are, and okay, all the 2, 3, 6, 7, 10 and for ground. The circuit is now finally pin number VCC. Pin number 5, connect VCC. Okay, now turn on the trainer kit and see here. Look at here, all zeros. Now I'll give the pulse input. Output is 1. Next again I'll give one more pulse. 2. Next again I'm applying the pulse. 3. More pulse, count 4. Up to which count? This is mod 6. So 0 to 5. See, again I am up clock pulse 10 to 0. 3, 4, 5, 0. This is the mod 6 design. Thanks for watching. Please do subscribe to my channel. Bell icon.
I am going to demonstrate how to add a circuit. So here we are taking combinational value 0001 will be the when you add 0 get when you add 01 bit high the output, and when you add 1 when you add the 0 1 when you add 2 bits sum and carry. Will relation for sum is equal to here 1 a is 1 a bar plus 1 a 0 means same as for that is output. So b is equal to 1 a b. For this connecting b and connecting to a bar take inverted output of a get input same as b directly input. So these are the two inputs and output is taken. Next a b bar and these two outputs were OR gates and b connected for carry will be up. Now we'll see the for NOT gate 04 is used at gate. Okay, 6 every IC we need to connect 7 to ground 14 for VC. Now first pin second pin 1 6 same as coming to 4 IC. First one the input pin is output. Here for coming to OR gate 7 IC 4 pins are input and the output. Again you can use 432 IC. Okay, now I'm 7 IC. So works be connected 40 is used as it 32 IC. I'll connect a circuit. That is first A given to first pin not A is connected AND gate for first input. A is connected for AND gate. That means 1, 2, 3. And next same A tapping a probe for AND gate. That is third, 8, 9. Now output of is A bar and connect it for gate first pin. Pin number 1 and IC. A is given. Now input B for NOT gate IC. Pin number 3 and this B is connected for first and gate second in B is connected to first and gate. Next B is connected and gate 12 inputs. Output that is from that is fourth, and for the second and gate is pin number 5. Okay, now and gate first and gate out for output, that means pin number 3 is the AND gate output for or first pin number 1, and the second AND gate that is 6 is given as second input for that is pin number, and gate out is sum, and same AND gate number 8 is taken as output in the all the 7th pin IC ground, and pin that means here 14 pin because it is 14 pin IC. So here see here 2 slots are empty. That means these 8th and 9th pin are not considered for all the ICs. So 16th pin becomes 14th pin. 14 pin were connected for VCC plus 5 volts. Switch on the circuit. Okay, switch on the trainer kit. Now we'll check the truth table. That is for 0 0 sum 0 carry 0. For 0 0 input sum 0 carry 0. Now give 1 for B, that is A B 0 1. We'll get sum 1 carry 0. Sum 1 carry 0. Next A is 1. A1 B0. So the output is sum 1 and carry 0. Now both inputs are 1. Sum 0 carry 1. Okay. This is the 0 0 1 0 1 1 0 1. Okay. Thanks for watching. Please do subscribe. Ushashri. Now I am going to demonstrate how to design the half subtractor hardware part, that is part B 4th Pro B 2 in 0 0 0 1 1 0 1 1. When you do subtraction, that is from 0 0, the difference is 0 and borrow becomes 0. When you subtract 1 from 0, the difference becomes 1 and borrow is 1. Next, when you subtract 1 from 0, the difference becomes 1 and borrow is 0. Now when you subtract 1 from 1, the difference is 0 and borrow is 0. Okay, now design the circuit. That is wherever 1, so difference. Now difference expression is equal to A bar B plus A B bar, same as borrow is equal to, that is A bar 1, where we will get output high, that is A bar B. Now we will design this using NOT gate for bar, AND gate, OR gate. Now we will connect first A bar, take one input A bar, B for AND. Okay, that is you can take pin number 1, 2 and 3. A B bar, take one input from 1 A and other input B bar, not get output. This is not get pin number 1, pin number 2, pin number 1, pin number 2. Okay. Now take here 4, 5, 6, 7 is ground. Next, borrow. Connect these two for OR gate. That is pin 2 and take the output from pin number 3. This becomes difference. Borrow. Take an input from NOT gate. First A bar, B, that is NOT gate. Only 4 are used, so becomes output 9 and 10 pins. Now this is the, we will design the hardware. NOT gate IC number 40 and 4087. Roll the, now I am connecting NOT 408 C side, not is this, and since 2 slots were empty, now 12 pins, 7th pin in and 14, 7, 14, 2, so 8, 12 not considering. So after 7th pin, 10th pin becomes the 8th pin. Okay, now I have connected VCC and ground. I will design the circuit. That is, first input, that is, take an input A and connect it for NOT gate first pin, and again AND gate fourth pin. Pin is for AND gate fourth pin. So from A input completed. Now A bar, that means second gate output taken, and that is first AND gate pin number 1. Okay, and next pin number 9, AND gate pin number 9. Pin number 9. After 7, this becomes 8 and 9. Next one, take the input B, next input, and connect it for gate third, and from this AND gate second pin and AND gate 10th pin, AND gate second pin, and the same for next input. That's it. B bar. B bar AND gate second AND gate second next input, that means pin number 5. NOT gate output is taken and given for pin number 5 AND gate. Now we'll connect first AND gate output and second gate AND gate output for OR. That is pin number 3 AND gate to pin number 1 OR gate, and pin number 6 output of AND gate as input of OR gate, pin number 2, and the output of OR gate, the output of gate, that is pin number 8, is borrow. Now switch on the circuit. Now we'll give the bell for 0 0 difference 0, borrow 0. For 0, 1, difference is 1 and borrow is 1. Okay. Next for 1, 0, difference 1 in tarvati. For 1, A1, B0. Okay. Now the difference is 1 and borrow is 0. If both inputs are 1, 1, difference 0 and borrow 0. Thanks for watching this video. Please do subscribe and share my video. Myself Ushashri. Now I am going to demonstrate how to design full adder hardware circuit. This is part B, 4th program C. Okay. This is the truth table, that is when you take the 3 bits, what is the sum and carry. By this we will get the sum expression like this and carry expression. Now I will design this according to the circuit of the sum and carry. Okay, this is the circuit diagram. Now I am going to design this. For this we need NOT gate 1 IC, that is 7404, and AND gate 2 ICs required, because from one IC you can connect 4 AND gates and from other IC you can connect 3 AND gates. And here we are using 2 OR gates and here 2 OR gates. 4 OR gates can be connected for 17432 IC. I am going to design this. Placing gate. See, 1740843 as use it. And gate. Okay, yeah. Input. And we need to same A input for AND gate. Same for AND gate number 1. Same for this is the second IC. You take other IC and A put. This is another AND gate IC. Again same connection for AND gate 11. Okay, output of that is A, and connecting first gate put AND gate second pin, and no other connections for A bar. Now take one more input, that is B, connected for NOT gate third pin, and what are here, that is AND gate input. Same B input is given for AND gate other input. For B another connections, that is for B take 2 inputs and 2 AND gates new ICs. Okay, same again connecting 2 more inputs connected for first AND gate of new IC, other second IC, and next fourth pin of. Now take the inverted, that is B bar, from the fourth pin of NOT and check the connections, that is AND gate and no other. Now give the input NOT gate connection C given for the fourth AND gate of first IC. So same, and that is fifth pin C is given for pin. and C again, that is C is connected for second AND gate. Again C is connected second IC, second AND gate, third AND gate, third AND gate. Input C is completed. Now take the inverted output, that is C bar, from the 6th pin of NOT IC and check the connections, that is third AND gate, third pin number 9, pin number 9 of C, and next no other connections from C. C bar, no other connections from inputs, inverted inputs. Now we'll connect all 7th pin, 14th pin VCC, 7 to ground, 7th pin grounded and 14th pin VCC, 7th pin ground and 14th pin VCC. Now we'll connect the remaining connections. Now we'll connect the first OR gate output to the NOT gate. This is the OR gate. Okay, first OR gate output, that is this first AND gate outputs were given as an input for OR gate, that is, and 6th gate is given as an 1 and 2 for OR gate. The 4th AND gate input, and one more again output for gate to get the output pin number 10, and it's given as an output for 4th pin of AND gate, pin number 13. Now the third AND gate output and 4th AND gate output were connected for OR gate. Okay, I am taking third AND gate output is and the 4th gate output is the OR gate input, and this output is taken as sum. Next, same as here, the second IC AND gate, first AND gate, second for OR gate, third pin of gate output, second pin of second gate output, and given for inputs, that is 9 pin number is taken as output and given for the OR gate, and one more AND gate, new AND gate output, that is taken and given as an input for OR gate. Output of this OR gate as carry. Now the connections were completed. Now trainer and check the truth table. Okay, puts 0, sum is 0, and carry is 0. 0, 0. Okay. Now for 0, 0, A, B, C, sum 1 carry 0. 0, 1, 0 carry 0. 0, 1, 1 sum 0 carry 1. 1, 0, 0 that is sum 1 carry 0. 0, 1 carry 1. 1, 1, 0 sum 1. All input 1 sum 1 carry. This is how to check the output for full adder. Thanks for watching my video. Please do subscribe. Now I am going to design full subtract hardware, that is fourth program part. Under that D, this is the truth table A and the difference and borrow. Okay, according to this are the ones that difference and ones for borrow expression. By using expressions, this is the diagram. Okay, actually this circuit is the same as full adder. See this? Okay. Okay, this is the full adder circuit and this is the full subtractor circuit. Actually the expression is same for difference and you check this and then for carry, see the expressions will change only when A full adder. It should be connected from A bar for borrow. The expression from A in A whole same difference when you come A B C A. Come to in A changing as well C A, that is B, here there it is changing A bar, and B C is constant. B C is constant. Okay, instead of C A bar C, and instead of A bar B. So I'll just change these connections, that is from full adder I'll change to full subtractor. When A input for AND gates I'll change to A bar and I'll show the both the outputs. Now we'll check the full adder circuit. Already this is, I have shown this full circuit designing in previous video. Please watch that video and just change these two connections. Yes, look at this circuit. I am switch on the trainer kit. Now I'll show the output, that is this is the truth table for full adder 001 10 010 10 11 01. Okay, go on, you check for 111, it should be 11. Okay, now this I am just changing the connections. Check randomly for one input, that is 101 for full adder. See here for 101 01. Okay, 01. Now I'll change this full adder to full subtractor, just that carry. Okay, that means A I'll give, instead of A input I'll change that A bar and I'll show the truth table for, see here for AND gate. First AND it is connected to A. This is connected for first A. Now I'll connect output instead of same as AND gate for both. Next AND gate, that is given from A, I am changing to A bar. Okay. This becomes the full subtractor. No need to change. Only the inputs you have given from A should change from A to A bar. That's it. Enough. Now we'll check the truth table. Which on the trainer case? Now check the truth table. The truth table for 0 0 0 full subtractor difference 0. Next for 0 0 1 difference 1 borrow 1 1 0 difference 1 borrow 1 1 difference 0 or 1 0 1 0 difference 1 borrow 0 difference 0 for 1 1 0 difference 0 borrow 0. Now all ones 1 1 where just change of A input to this full sum. Okay, watching. Please do subscribe and share my video. Shashri non-state A plus program, that is the fifth program for wheatlands. Please do channel and click the share this video. Now for this designing we need multiplexer IC, that is 74151 IC. Okay, this consists of 3 select lines, 4 to 7, that means 8 data lines. These are all data inputs, 1 output and 1 enable. For this we need 8, that is IC 7404 IC. Now first we need to design, that is for 4 inputs A, the expression is given y is equal to f of ABCD summation of SOP expression 2, 4, 5, 7, 10, 14. That means for this data inputs we should get output high and for all remaining it should be 0. Okay, now this is the, now we are entering the variable, that is, see here for 2 this 0 1 2 we should get 1 and 4 1 5 7 10 14. For this the output should be high and for remaining it should be low. Now we will enter MEV, map entered variable method. Using this method we are entering the values. We should take this. Now this is the rules for enter K-map method. Okay, see, if the two values 0 0 1 0, that means here 0 0 you should enter value 0. If this value is 1 you should enter 1. If both the values 0 and both the values 1, that means what is the value MEV, same it should be entered. If suppose this is inverse 0 1 1 0, enter inverted value. Suppose if you are using don't cares, then 0 1 don't cares means don't care, 0 1 0 don't care, here it is 0 0, so 0. Next 0 don't care, 1 don't care, so it is 0.
0 1 1 don't care 1, 0 don't care 1 1, it should be entered 1. Now using this MEV K map, we are entering here the values, that is 0 0 1 0. This combination it is 0, so you should enter 0. Okay. Now 0 1 1 0 inverted values, so D bar. Because this is inverted, 0 becoming 1, 1 becoming 0. So it is entered D bar. Next both are 1, so you should enter 1. Next these two values 0, these two 1. Input as well output same, so you should enter D, same value D. Next here 0 0, so enter 0. Inverted value and 0, so in bar 0 0, so you should enter 0. Again all the data lines D 0, D2, D3, D4, D6. This will multiply data lines in the circuit using the designing. Designing the 8:1 multiplexer, we need one NOT gate IC, that is 7404. See the notch here and place and lock this. As next multiplexer IC, this is 74151. Notch upside, place here. Okay. Now according to the circuit design, first we need to give the D input. I am taking here D. Input is connected for NOT gate first pin, and the same input, see the circuit diagram, the same data input is given for pin number 1. 1 means that is pin number 1, data line 2. In this data line 2 is 1. So we are connecting okay. MEV, see this D same input D is applied for D3. D3 is pin number, okay, pin number 1. So I am connecting to pin number 1. Coming to bar, inverted take NOT gate as well D7. And connect pin number 14 and pin number 12. Okay, so D bar is connected. Now we'll see 1 MEV input is for D2. D2 is pin number 2. 1 means you need to connect for VCC. So pin number 2. As well, for all ICs you should connect 16 pin VCC, and for 14 pin IC, 14th pin is VCC
because 14 pin slots were empty. So 8 and 9 pins are not considered here. So this becomes 14. For 14 pin I said 4, and then the pin all ICs 14 pin. Suppose it is 8 pin should be ground. Okay. Now we should next is that is 0. This data input 0 0 and data D40 D60. These 3 pins should be 0. That is 7. 4 is enable. 15 enable 0. Next 30 pin number 15 and 4 are the here and pin enable it should 0. So all should be given for 0 means ground. Now we should connect for A pin number A, 9th pin input A, tenth pin in B, seventh pin input C. So A, B, C, D were connected. Now output is taken number 5. Pin number 5 output pin connected. So 9 pin inputs and D input as well not is given for input for IC 8:1 multiplexer. Output is taken from 5th pin. Now we will check the output. Switch on the trainer key. Okay. Now check the values. 2, 4 and 14 we should get output 1, and for remaining all we need to get 0. I am checking for this is 0, 2. Output should be high. Okay, next 3 output should be low. Next 4 output should be 1. 5 output should be 1. Next should be low. For 7, 8 low. Okay, it should be next. For all it should, and for in it should be, that means this is the 14 high. This 8:1 multiplexer and subscribe. Thank you. Now I am going to design JK master slave flip flop using NAND gate. Here we are using two types of 2 0 gate I0. 2 input NAND gate is same connections, that is pin number 1 and 2 are the inputs, 3 is the output. Go on like that. By 3 input NAND gate, pin number 1, 2 and 13 are the inputs, 12 is the output for NAND gate, 3 are the, and 6th pin for second NAND gate, 11, 10, 9 and 8 is the output. This is the IC configuration. How to design the master pin number 4 pin IC 7410, 3 input NAND gates only, that is 0. The closing NOT gate. Okay. Now for this NOT gate, connect that 14th pin. The pin 2 slots 9 were not used. 7th pin, and then give the clock input 1 heads. This again, take this, that is pin number 2 NOT gate, and give the clock or AND gate number 2 and between that is pin number 2 or connect. Okay, this is clock, inverted clock given for pin number 2 and pin number 4. Clock given the clock, that is for pin number 13 and 3. Pin number 3 again applied for pin number 13 IC. Next, input, that is pin number 2, input J. Next, same as input K, that is pin number 4. Input J. Now connect 1 for pin number 10. Number 1, 2 input and 10 means because pin IC. Next, pin number 5, given for pin number 12. Pin number 5, 2 input AND gate, pin number 12, 14. Next, pin number 12 means 14 of 3 is given for the next 3 input AND gate, pin number 2. Next, 1 of second is set, preset. And next, pin number 13 of second IC is given for 6. 13 means 15 is given for number 6. Same IC. But 12 is given as 3 for the and 5 clear. So I and pin number 6 of first AND gate output say given as input of the 4. Now connect 16 for that is 14 pin and 7th pin for ground, 7th pin ground, 14th pin VCC. So this AND gate, that is master, is completed. Now we'll see the slave. NAND gate, that is second NAND gate, 12 pin number 12 output, and as 12 means 14 for the NAND gate, that is 2 in 7 6 out NAND 2 is given as input, that is pin 2 input. Now output, that is NAND gate third pin output as a input of gate, that is 10. 10 means okay. Pin number again pin number 3, that is output is taken and connected for the NAND gate. Next NAND gate, pin number 9. Now pin number 10, from pin number 10, but 10 means 12. Already it is given from 3 and 3 input NAND gate, that is given for. Next, now pin number 8. Pin number 8 means 10 is given for pin number 14. Already one of the income 3. Next, pin number 6, that is output of the 2 input NAND gate is given as an input. 13 means 15 input NAND gate. Next output, that is pin number 11. 11 means again the same. Pin number 11 means 13. That is Q bar. Here connect the output Q. Now pin number 8. Then from pin number 10 take the Q. Now this and is ground. So now when you apply, that is once it will be working master when you give the positive clock, and again if you give the clock pulse, that is negative will be working always should set that preset. These two are preset and clear high value. Okay, and use the switch on the trainer. Check the truth table. Always preset and clear should be 1 high. Okay, now we'll see here J K 0 values. So master and slave will be inactive. So it won't change. Okay, when we apply, that is clock pulse is 0. See here, clock is applied 0 0. It will be in the change 0, that is Q and Q bar. Now I am changing the input 0. K1 the clock. Now see the output reset Q0 and now values J0 and apply. It will be Q1 and Q0. J and K values and apply the remains it and 0. And the output for the master slave. Thank you.
Shashri, now I am going to demonstrate to design the circuit binary to gray code conversion. Part B 7. Now example, any binary value that is 1 1 0 0 I am taking. So naming it as B0, B1, B2, 3. Okay. In this, how we are converting this binary to gray is using XOR operation. That is, first bit keep as it is 1 and do this 2 bits exclusive OR. So the output is again exclusive OR with this 2. 1. So value is output 1. Again 0 1. The output is 1 Y. This is the gray code. G3, G2, Z1, Z0. For this we see 7408. This is 14 pin IC and we are using 7 IC. This is NOT gate. 14 pin IC, 74 IC, OR gate, 2 input OR gate, in the first pin input, second pin input, and we are taking output from third pin. Same as 4th pin, 5th pin inputs, 6th pin take output. Always 1 pin and 4 given VCC. Into next part of becomes in be the output. Same as inputs is output. For this, that is 17, 14 pin or 1, 2 inputs output, 6 output, 9, 10 output, 12, 13 input, 11 output and 4 output. Only we are giving and invert. So first pin input, third pin output. Likewise, you can connect NOT gates. AC should be ground and 14 pin will be for binary. Okay, see here we are for B0 to B gates for this using AND gates or gates, getting the gray given 0 to 0. How to connect? Here I am using the pin number, that is 74 IC, not 74. See the okay, 2 were not connected. same as this is, and remaining 4 two ICs, that is 4. Place here, close this, and again this is also for AND gate 7404. Place here and next we are using 7432. Now we'll see the connections according to circuit diagram. According to this circuit, now I am designing the D3. Okay, given for NOT gate input pin number 1, and pin number 1, what are all the connections required, that is G3 output and second AND gate input, giving G3 tapping here, for tapping for AND gate, is gate 1, gate 3rd pin. Next, output of NOT gate, okay, that is second pin of is taken as, here this is connect gate first, no connection, inverted of first NOT gate, connecting B2 input, B what are all the inputs gate, first AND gate, fourth AND gate. So we need to take two tapping probes, first AND gate input, first AND gate, one of the input, next one fourth AND gate, that is fourth AND gate input, either 14th pin. Okay, in the B2, that is second AND gate input as well. So from this NOT, second AND gate input, and again one more and gate AND gate input. First AND gate outputs were connected, that is first and second AND were connected for OR gate 1, and output OR gate output is taken as, okay, all ICs don't forget 7th pin, pin, connect 7 pins for ground, 14th pin for VCC, now we'll connect the remaining B1 and B2 as same. So the Now the connections were completed according to the circuit design. I'll switch on the trainer kit. We'll check the output according to the truth table. Randomly we'll check one. Okay, 4000000001 same, and 0010, the output becomes 0011. 0011 it should be 10, 0010. Next 0, the output should be 0, 01, 0, 111. The last is according the design properly. Thanks for watching. Please share the video.
Myself Ushashri. Now I am going to design binary conversions where the this is the truth table. That is how this truth table is constructed. I'll give one example. Any one value, that is 1. First, keep the first bit as it is and do the exclusive OR on these 2 bits. So exclusive OR operation will get 1. Next again exclusive OR bits 0 0 0, same. This is the 0 binary. Gray code is taken and converted into binary code. This is how the truth table additional value 4 taken as a truth table, and by this using this and K-map is designed. This is the circuit design. After minimizing by using and this circuit, we are one IC, not IC, 2 ICs. There is gate ICs. Okay, 7404 is connected here and 740808 here is the OR gate. I am doing the connection circuit. So I'm from this side B3, B2, B1, B0 as in name, Z3, Z2, Z1, Z0 as output. G3 gray code to version G3 as input and not gate. And what are all the connections? Okay, according to the circuit, G3 inputs the G3 output. And one more connection, that is for AND gate, connected for AND gate, that is pin G3 for completed the connection. Invert G gate out pin number. What is first pin number AND gate, first AND gate input. That's it, completed. Next in G2 pin number 3 and what are all for Z3 first and so when G3 first AND gate input and the first can as an input of OR gate, that is the last. Okay. And the same G3 input is completed. Now NOT gate, that is connected for second and is pin number 5. One connection. This AND gate even put one of the input for OR gate. OR gate output taken as B2 binary 2. Next and same gate output connected input not put given and next and gate is pin number 9. Again the same output is for the AND pin number 9. again give and get in. I'm taking connection. Okay, now play. I'm taking one G3 to the pin number 9, that is not get input, and that is G1, sorry Z1. What are all the connections? And one input, the same input of one of the gate already not this is not get, so one. Now output is given for new OR gate input. Only one connection from G1. Now G1 inverse is not get output taken. It is connected for AND gate. This means AND gate input. This is the AND gate input, and that AND gate output is given for OR gate input. Okay, and this OR gate output is taken as output pin output, and this is given for NOT gate, and that inverted output is given to output AND gate, and the same output of OR gate is taken and given for one more new AND gate input. And now taking the last input gray Z0 input and connecting to the not not get input, and for this we will check the connections. That is only one connection for the input. So I'll connect connection from the NOT gate input, and it is given for OR gate, sorry, and gate input, and this output is given for another AND gate. Now gate 2 AND gate outputs were taken from pin number 8, 11 and given for OR gate input. Nine and 10. This output, that is 8 pin, can as B not output. Now connect all the ICs 14 pin for VCC and 7 pin for ground. Switch on the trainer gate and check the output. According to the table, all 0 should be 1. It should be 1, 1, 1. It should be 0, 0, 1, 0. 1, 1 be 0, 1, 1, 1. 0 1 1 1 1, it should be 0 1 1 0. 3 ones, 0 3 ones, 0 1 0 1. 1 0, it should be 0 0 1 1 1 1 0. 1 1 1 0. 1 0 1 0 1 1 0 0. 1 0 1 0. Next 1 0 1 1, it should be 1 1 0 1. 1 1 0 1. 1 1 0 0, that is for 10, should be 1 0 0 0. 1 1 0 1, it should be 1 0 0. 3 1 0, it should be all ones, it should be 1 0 1 0. This is the circuit design and output truth table. Thanks for watching. Do subscribe and share.
Today I am going to design the synchronous mod 5 counter hardware part B 6 program. According to this truth table, mod 5 means count starting from 0 to 4. 0 1 2 3 4, and then again it should start with 0 is the count value, 0 to 4, and then when count is 5, that means it should display 0 0 0. This is the design of the circuit. 7476 IC, that is we can connect two JK flip-flops, these two, and set up again with JK flip-flops, but we are using only one JK flip-flop, and for this AND gate, okay, we are using 7408 IC. Okay, now I will show how to design the circuit. See, check the notch and place the 7476 IC. This is 16 pin IC. Notch and place the 7476
get give the 7th ground connection, and then for 14, this is 14 pin IC, 16th pin becomes the 14 pin. Here two notches were, that is 8 activated, so no need to cut. And now according to this circuit, okay, first I'll give the clock, that is clock 1 heads for pin number 1, pin number 6, for the second 7/4 IC. 1 for first IC, 1, and pin number 6. Give for input, that is monopulse high, connect for 1 hedge. This all pins were 1 hedge. This clock is applied. Clock is applied, 1 heads. Now design the pin number 4 connected for the second IC, pin number 14, that is QC bar. This is pin number 14 connected for pin IC 4. Next, pin number 16, you have to give the high. High is nothing but you can give VCC. Next, same as second IC, again you connect 16th pin high, okay, because these two are the given. And next, we'll see preset clear. Clear is pin number 3, pin, and pin number 8 of first IC, as well the second IC pin number 3 were connected to input, that is high. Again this is high, clear, high. Okay. Okay, given for clear, and now I'll connect for preset. Preset is pin number 2, 7. Pin number 2 of first IC, same as pin number 7 of first IC. Pin number 2 of second IC. Pin number 2 of first IC, as well 7 of and again 2. These 3 connected preset. Okay, connect for preset. Now take the 15th pin as the output. 15th pin output QA bar. Okay, 15th pin, tap and connect for 1 and get input again tap and connect, give for IC input pin number 9. That means here in the same IC pin number 9 and is given for the same IC pin number 12. Pin number 12, tap this same. Okay, next second IC output is pin number 11. Pin number 11 and give it to the and gate and get second pin input. Next same pin number 11, tap one more and take it as output QB. Now connect second IC of pin number 15. That is the output QC. Output and QC bar 14 already it is given, that is pin number 4 feed batch. This circuit design. Now we'll switch on the circuit, the output. Check the output. That is always preset and clear should be high. See here. First 0, 1, 2, 3, 4, 0. This is how to check the output for synchronous mod 5 up counter using 7476 IC. Thank you.
Myself Ushashri. Today I am going to demonstrate how to design the circuit mod 6 asynchronous counter part B 9th experiment. This is by hand, but I am doing by using bits, output bits. For this we are using 7490 IC. Okay. So this notch, connect this upside. This is 14 pin IC. So leave down two pins and connect this circuit diagram according to this circuit. Now we need to give the output, that is for 14th pin. So I am connecting 14 pins. Here we are leaving two pins. So it becomes 16th pin. 16th pin clock, that is high. This is 1 Hz. Mono pulse is given 1 Hz. Next, pin number 1 is connected for pin number 12 taken as QA. Connect pin number 1, connect it for pin number 12, that means 14, and it is taken as output QA. So this is QA. See here, logic outputs, so you need to connect output pin. Okay, connect this QA this side. Next, QB. Okay, so this QB is connected from 9th pin. 8, 9. 9th pin. Next, 8th pin is connected as QC. Eleventh pin is connected as QD. 8, 9, 10, 11th pin. Okay. These are all the outputs. Now, we need to connect two, 3, 6, 7, 10. So pin number 2, pin number 3, number 6, pin number 7, and pin number 10, 8, 9, 10. All are tapped and connected to ground. ఆపేవమ్మా. Okay. All the pins 2, 3, 6, 7, 10 tapped and given for ground. This is what the design. Now finally, pin number 5 for VCC. So pin number 5, connect. Now okay, now turn on the circuit. Okay, and see here, look at here, all zeros. Now I'll give the pulse input. Pulse 1, output is 1. Next pulse 2. Next pulse, output 3. Again applied one more pulse, count, that is 4. Up to which count? This is designing mod 6. So 0 to 5. See, again I am applying clock pulse, monopulse, and then into 0. 1, 2, 3, 4, 5, return to 0. This is the mod 6 design. Thanks for watching. Please do subscribe to my channel and click the bell icon. Share this video. Thank you.
Myself Ushashri. Now I am going to demonstrate how to execute half adder hardware circuit. So here we are taking A B inputs. So combinational values 0 0 0 1 1 0 1 1, and what will be when you add 0 0 bit, will get 0 output. When you add 0 1 bit, high, the output will be high, and 1 with a 0, out 1, and carry is 0. When you add 1 1, the sum will be 0 and carry is 1. This is what when you add 2 bits, sum and carry. High outputs, okay, we will write the expression for sum. Sum is equal to, okay, here 1 means here A is 0, B 1. So A bar B plus A1 B 0. So A B bar 0 means B bar. Now same as we'll write the expression for carry, that is only one output. So that is A B is equal to 1. So direct B. For this, when you design the logic circuit, taking A and connecting to NOT gate, B and connecting to NOT gate. Okay. Now A bar B. Take inverted output of A to AND gate input, same as B directly input. So these are all the two inputs and output is taken. Next, A B bar connected for and these two outputs were connected for OR gate. This becomes sum, and Coming to carry, for AND gate, and carry will be obtained. Now we'll see the pin not gate. No. 7404 IC is used as not gate IC. Okay, here we can connect 6 not gates. For each 14 pin IC, we need to connect 7th pin to ground as well 14th pin for VCC. Now second pin is output. Go on, you can connect 6 not gates. Same as coming to 74 IC. First 1 and 2 pins are the input and the third pin is output. Same as here we can connect gates. Coming to OR gate 7432 IC. First 1 and 2 pins and the third pin becomes the output. Go on like that again. You can connect OR using 7432 IC. Okay, now I am taking 7404 IC, placing here. So it works, can be connected by using this. Now 7408 IC. This is used as AND gate. Seven four three two IC for now I'll connect it according to the circuit. That is, first A input and given to first pin of NOT gate and this A is connected for second AND gate first input. Same connected for second AND gate. That means 1, 2, 3, 4th pin and next connect same A, tapping a probe, connect it for third AND gate first pin. That is third. This is the 7th pin. 8th pin becomes output. So 9th pin. Now take the output of NOT gate, that is A bar. A bar, and connect it for first AND gate first. That means pin number 1, and IC. That's it. A is given. Now connect one more input B. Not gate IC, pin number 3. And A is connected for first and gate second input. The same B is connected to first AND gate second pin. Again the same B is connected for the third AND gate. Third gate. Okay, this is 11, 12 inputs. Take the inverted output, that is from NOT gate, that is fourth pin, and connect it for the second AND gate second input, that is pin number 5. Okay, now AND gate output is given for OR gate input, that means pin number 3 is the AND gate output given for OR gate first put, and the second AND gate, that is pin is given as second input for OR gate, that is number 2. And now this OR gate output pin number 3 is taken as sum, and same as AND gate third AND gate, that is pin 8 is taken as output carry. Now please connect all the 7 pins to ground. Okay, connecting all the 7 pins, 7th pin of each IC to the ground and 16th pin, that means here 14 pin, because it is 14 pin IC. Here, see here 2 empty. That means these 8th and 9th pin are not considered for all the ICs. So 16th pin becomes 14th pin. 14 pin were connected for VCC plus 5 volts. Now okay, switch on the trainer key with the truth table. That is for 0 0, some for 0 0 input, sum 0, carry 0. Now give 1 for B, that is A B 0 1. Will get sum 1 carry 0. Next A1 B0, so the output is sum 1 and carry 0. Both inputs are 1. Sum, okay, this is the zero 0 1 1 1 0 1. Thanks for watching. Please do subscribe and share my video. Self demonstrate how to design the half subtractor hardware part, that is part B, 4th Pro B experiment. Okay. 2 inputs A B 0 1 1 0 1 1. When you do subtraction, that is from 0 0, the difference is 0 and borrow becomes when you subtract 1 from 0, the difference becomes 1 and borrow. Next, when you subtract, the difference becomes and borrow is 0. Now when you subtract 1 from 1, that is 1, sorry 0 and borrow is 0. Now design the circuit, that is wherever 1, so difference, the circuit is now expression is equal to, okay, A plus A B bar. Same as borrow is equal to, that is A bar 1, where we'll get output high, that is A bar B. Now we'll design this using not gate for bar and gate or gate. Now we'll connect first A bar, take one input A bar B for AND gate. Okay, that number 1, 2 and 3. Same as A B bar, take one input from 1 A input B not get output. This is not get pin number 1, pin number 2, pin number 1, pin number 2. Okay, now take here 4, 5, 6, 7 is ground. Next, borrow. Connect these two for it. That is pin number 1, 2 and from pin becomes difference. Take an input NOT gate A bar B, that is NOT gate input pin and connect with AND gate. Already 1, 5, 6 pins were used, so 8 becomes output, 9 and 10 pins. Now we'll design the circuit hardware by using NOT gate IC number 7404 and AND gate 7408 OR gate 7432. Okay, these are all the ICs. Now I am connecting NOT gate IC 7408. See, the notch is upside notch. Okay, connect this. Notch is upside, connect this here and see, for all pins 2 slots were empty. Now connecting all pins, that is 7th pin is ground and pin VCC, 7th pin ground, 14th because 2 negligible, not considering. So the pin, 10th pin becomes the 8th pin. VC and ground. I'll design the circuit. First input, input and connect it for NOT gate first pin, and from there again AND gate 14. The same is connected for AND gate 4. Input completed. Now A bar, that means second pin of NOT gate, inverted output taken is first AND gate pin number 1. Okay, and next pin number 9, AND gate pin number 9. Pin number 9. After 7 it becomes 8 and 9. Next one, take the input B, next input, and connect it for NOT gate, third pin, and from this and get 10 pin and get second pin and the same for and get next input. Next, from B bar. B bar get get second next input. That means pin number 5. Not get output and given for pin 5 and get. Now we'll connect first and get output and second get for OR. That is pin number 3 and get to pin OR get and pin number 6 output of AND gate as input of OR gate, pin number 2 and the output of OR gate pin number 3 is taken as the output of third AND gate, that is borrow. Now circuit and check the truth table. Now we'll give the truth table, that is for 0 0 difference 0 borrow 0, for 0 1 difference and borrow is 1. Okay, next difference 1 for 1 A1 B0. Now the difference is 0. If both inputs are 1 1, difference 0 and borrow 0. Thanks for watching this video. Please do subscribe and share my video. Myself Ushashri. Now I am going to demonstrate how to design full adder hardware circuit. C. Okay. The truth table, that is when you take the 3 bits, what is the sum and carry. By this we will get the sum expression and carry expression. Now I will design this according to the circuit of this sum and carry. Okay, this is the circuit diagram. Now I am going to this. For this we need NOT gate 1 IC, that is 7404, and gate 2 ICs required, because from one IC you can connect 4 AND gates, and from other IC you can connect 3 AND gates. And here we are using 2 OR gates, and here 2 OR gates. 4 OR gates can be connected for 1 7 4 3 2 IC. Now I am going to design this, placing this NOT gate, NOT IC, 1 74084 and 7432 for R, and 7408 as use it, and I am connecting A input A for NOT gate, okay. A is connected for input, and need to connect that same A input for AND gate, for AND gate pin number 1, next same for this is the second IC, you take other IC AND gate, so A same input for this is another AND gate IC 7408, again same connection for third AND gate pin number 11. Okay, take the output of NOT gate, that is A bar, and for first gate another input, and gate second pin, and no other connections for A bar. Take one more input, that is B, connected for get third pin, and what are all the connections check here, that is AND gate input. Same B input is given for AND gate other input. For B another connections, that is for B take two inputs and two AND gates, new ICs. Same again, connect two more inputs, connected for gate of IC, other second IC, and next fourth pin of AND gate. Now take the, that is B bar from fourth pin of NOT gate and take the connections, that is AND gate fifth pin and no other connections. Third input for NOT gate, and check the connections C given for the fourth AND gate of first IC. So and that is fifth pin C is given for 14th pin and gate. C again C is connected for second IC of second third AND gate. Again C is connected for second IC of second AND gate and third AND gate. Input C is completed. Now take the inverted output, that is C bar, from the sixth pin of not IC and check the connections, that is third AND gate third AND gate, that is pin number 9, pin number 9 of AND IC. Next, no other connections from C. No other connections from C bar. Now inputs A, B, C and inverted inputs were completed. Now we will connect all 7th pin ground and 14th pin to VCC. 7th pin to ground and 2 VCC. Seventh pin grounded and 14th pin 7th pin ground and 14th pin VCC. Now we'll connect the first gate output to the NOT gate. This is the OR gate. Okay. First OR gate output, that is this first AND gate and second AND gate outputs were given as an for OR gate, that is the third and sixth pin of is given as an input and 2 for OR gate, and the output is for the 4 AND gate input. And one again the same is given for NOT gate to get the inverted output, that means 10, 9, and 9 is given as input, and output not get is given for fourth pin of AND gate, pin number 13. Now the third AND gate output and fourth AND gate output were connected for OR gate. Okay, I'm taking third AND gate output is given for OR gate, and the fourth AND gate output is given for the gate input is taken as sum. Same as here. The second IC AND gate, okay, first AND gate, second AND gate connected for OR gate. Second AND gate output and second pin of second IC AND gate is taken output and for gate inputs, that is 9 pin numbers, and 8 is taken as output and as an input for the OR gate. One more AND gate, new AND gate output, that is taken and given as an OR gate, and the output of this OR gate
is considered as carry. Now the circuit connections were completed. Now switch on the trainer kit and check the truth table. Okay. For 3 inputs 0, sum is 0 and carry is 0. Is 0. Okay. Now for 0 is A, B, C. C is 1. Sum 0. 0, 1, 0. Sum 1 carry 0. 0, 1, 1. Sum 0 carry 1. 1, 0, 0. That is sum carry 0. 1, 0, 1. Sum 0 carry 1, 1, 0. Sum 0 carry 1. All input ones. Sum 1 carry 1. With the output for full ladder. Watching my video, please do subscribe and share my video. Myself Ushashri. Now I am going to demonstrate how to design full subtractor hardware, that is under the D. Okay, see, this is the truth table for full subtractor. Okay, 3 inputs A, B, C, and what will be the difference and borrow. Okay, according to this truth table, wherever the ones becomes the difference expression and ones the borrow expression. Okay, and by using this expressions, this is the circuit diagram. Okay, actually this circuit is the same as full adder. See this? Okay. Okay. This is the full adder circuit and this is the full subtractor circuit. Actually, the circuit design and the expression is same for difference, and you check this, and then for carry, see the only wherever you are connecting A for full adder, it should be connected from A bar expression. I am seeing A exclusive or B into C bar plus A exclusive or B whole bar into C. Same is for difference.
come to carry, AB plus BC plus A. But when you come to in full subtractor, A bar C, A is changing to A bar, as well CA, that is A bar B. Okay, here wherever A it is changing A bar, and BC is constant. BC is constant. Okay, instead of CA, A, A bar C, and instead of A bar B. So I'll just change this connections, that is from full adder I'll change to full subtractor. Where I have given A input for AND gates, I'll change to A bar, and I'll show the both the outputs. Now we'll check the full adder circuit. Already this is I have shown the circuit design in previous video. Please watch that video and just change these two connections. This circuit already designed. I'm switch on the light. Now I'll show the output, that is this is the ladder. Okay, 0 0 1 0 0 1 1 0 0 1. Okay, go on. You check for 1 1 1. It should be 1 1. Okay. Now this I'm just changing the connections. Check randomly for one input, that is 1 0 1 for full adder. See here for 1 0 1 0 1. Okay, 0 0 1. Now I'll change this full adder to full subtractor. Just that carry. Okay, that means A I'll give, instead of A input, I'll change that A bar, and I'll show the truth table for full subtractor. See, for AND gate, first AND gate, okay, it is connected to A. This is connected for first NOT gate or NOT gate pin number 2 instead of 1. Same as AND gate. Okay, for this is for
borrow. I'm changing this. That is one input, that is given from A. I'm changing to A bar. This becomes the full subtractor. No need to change. Only the inputs you have given from A should change from A to A bar. That's it. Enough. Now we'll check the truth table. Switch on the trainer kit. Now check the truth table. Truth table. From the truth table for 000 full subtractor, difference 0 borrow 0. Next for 001 borrow 1. Next for 1 0 1 borrow 1. For 1 1 difference 0 borrow 1. For 1 0 0 difference 1 borrow 0 1 difference 0 borrow 0 for 1 1 0 difference 0 borrow 0 once 1 1. That's it. Very simple. Change the connections of full adder A input to A bar input. This becomes the full subtractor. Okay. Thanks for watching. And myself Ushashri. Now I am going to demonstrate 8:1 multiplier program, that is part B, 5th program for VTU 3rd semester students. Please do subscribe to my channel and click the bell icon. Share this. Now for this designing we need multiplexer IC, that is 74151 IC. Okay, of 3 select lines 0 to
7, that is 8 data lines. These are all data inputs. One output and one enable. For need not gate, that is IC 7404 IC. Now first we need to design, that is for 4 inputs ABCD, that is the expression is given y is equal to f of ABCD summation of SOP expression 2, 4, 5, 7, 10, 14. That means for this data inputs we should get Y output high, and for all remaining it should be 0. Okay. Now this is the now we are entering the variable, that is, see here, for 2, this is 0, 1, 2, we should get, and 4, 1, 5, 7, 10, 14. For this the output should be high, and for remaining it should be low. Now this is the Y output. Now blend MEV, map entered variable method. Using this method we are entering value. For this we should take D as well as Y. And now okay, this is rule K map using MEV method. If the two values 0,
1 0. That means here a function 0 0. If this value is 1, both values 0 and both the values 1, that means what is the EV? Same, it should be entered. If suppose this is inverse 1, we should enter the value inverted value MEV bar. Suppose if you are using don't cares, then 0 1 don't cares means don't care, 0 1 0 don't care, here it is 0 0, so 0. Next 0 don't care, 1 don't care, so it is 0 0 1 1 don't care, 1 0 don't care, 1 1 it should be entered 1. Now using this MEV K map, we are entering here the values that is 0 0 1 0. This we enter 0. Okay, now 0 1 0 inverted D bar. Because this is inverted, 0 becoming 1, 1 becoming, so it is entered. Next both are 1, so you should enter 1. Next these two values 0, this that will output same, so you should enter D. Value D. Next here 0 0, so take it value 0. Now 0 1 and changing 1 to 0, so inverted D bar. Here 0 0, so you should enter 0. Inverted value again D bar. Okay, so these are all the lines D naught, D1, 2, D4, D5, D6, D7. Okay, this should be IC. Okay, now is the circuit. Using this designing. Designing the 8:1 we need one NOT gate IC, that is 704. See the notch here and place and lock this. Next, multiplexer IC. This is 7151 notch upside. Place here. Okay, lock this. Now, according to that, we need to give the D input. I am taking here D. Input is connected, NOT gate, and the same in see the circuit diagram. The same data input pin means the data line 2. See here, data is 1. So okay, according this D, that is for D3 is pin number D3. Okay, number connecting to 1. Coming D bar, that is port taking from NOT gate D, D5, D7. So D and connect for 3, 14 and 12. Okay, so D bar is connected. We'll see 1 MEV input is for D2 is pin number 2, means you need to connect for VCC. VCC pin number 2. As well, for all ICs, you should connect 16 pin VCC, and for 14 pin IC, 14th pin is VCC, because 14 pin here slots were empty, so 8 pins are not considered here. So this becomes 16 becomes 14 for 14 pin IC, so connected for VCC, and then 7th pin ground for all ICs. 14, suppose it is 16 pin IC, 8 pin should be grounded. Okay, now we should connect next remaining pins 0, D naught, that is data input 0, 0 and data 40, D60. These 3 pins should be 0. That is pin number 4 is enable. 15 enable we are considering. Next pin number 13. Okay, pin number 13, pin number 15 and pin number 4 are the data lines here 0, and 7th pin is enable, it should be again 0. So all should be given for 0 means grounded.
Now we should connect for A 9th pin, input A, 10th pin, input B, 11th pin, input C. So A, B, C, D were connected. Now output is taken from pin number 5. Pin number 5 output pin connected. So 9 pin, 10 pin, 11 pin, and D input as well not is given for input IC 8:1 out 5th pin output. Switch on the trainer key. Okay, now check the values. Output Y. See here, for 2, 4, 5, 7, 10, 14, we should get output 1, and for remaining all low 0. So I am checking for 0, 1. Okay, now 2. Output should be high. Okay, next 3 output should be low. Next 4. 4 output should be 1. 5 output should be 1. Next 6 output. For 7 it should be 8 low, 9 low. Okay, for 10 it should be high. Next for all it should be low, and for only 4 should, that means this is the 4. Okay, how to design output video, and now I am going to